Your Tesla just swerved to avoid a biker before even you saw them. Your iPhone unlocked even though your face was half covered by a blanket. Today we are breaking down the battle CNN versus Vision Transformers. Which one's running your car? Which one's running your phone? And most importantly, which one is our future? Let's start at the beginning. To you, this is a picture of an extremely cute cat.
But to a computer, just math.
Every image is just a grid of pixels. Each pixel is made of numbers, red, green, and blue, from 0 to 855. You see, AI doesn't see our eyes for the whiskers, it sees patterns in these numbers. And that's where neural networks come in. CNNs are convolutional neural networks are the first to crack the code of image recognition. Think of CNNs like detectives with a magnifying glass. They scan the image one small piece at a time for careful clues. They build up complexity. First they look at edges, then shapes, then do patterns like for our eyes, and eventually the system says, that's a cat. They're fast, efficient, everywhere. From facial recognition to your Snapchat filters, CNNs are doing visual everything. Now let's meet the new hotshot, the Vision Transformer and the VIT. Instead of scanning the image bit by bit, Vision Transformers break it into patches and look at all of them at once. Let's go more into depth as to how it exactly works. I already showed you how the Vision Transformer breaks up the image into patches, but here's the problem. Transformers don't really know about order or position. Unlike CNNs, they don't know which patch came from where, so we need to inject that info manually. And that's where position embeddings come in. We add a vector to each patch embedding that tells the model that, yo, this patch came from 3, this one's from patch 17, and so on. Now, to pass on the linear patch into the transformer, it's not as simple as just inputting. Instead, we have to do something else. Converting to numbers, more specifically, vectors. Each of those 16 by 16 patches are flattened into a vector, like unrolling a tiny poster into a line. Then we pass each one through a linear layer, aka a basic neural network layer, to get a fixed length embedding. These are the image equivalents of board embeddings in NLP. Now we have 16 of these patches, all converted into linear vectors, ready to represent the image. To be honest, first this is done in the positional embedding, but I kind of made a mistake in the animation and I was seeing to fix it. So finally, we have something called a CLS token. It's like a blank patch that's inputted in the beginning, and it says, hey, I'm just here to gather all the vibes and summarize this whole image. During training, the model learns to use the CLS token to make predictions. And now the magical part of VITs, self-attention. Each token asks, what other patches should I be paying attention to? It calculates attention score between all pairs of patches that lets the model understand global context, how one part of the image relates to another. This is how they work. And we just don't do this once, we do something called multi-head attention, where there are many perspectives, such as one head might focus on shapes, another on whiskers, edges, colors, and so on. And once it processes through these layers, the model looks at the CLS token, which now holds all the context, and makes the prediction. Inputting in the CLS token into the transformer generates a softmax output, where it sees the probabilities of what the object could be, whether it's a cat or a dog, and chooses the highest probability. Finally, let's compare CNN versus VITs, now that you know how they both work. CNNs are masters of local patterns, edges, corners, textures. They work by using sliding filters, and they're more better for smaller datasets. CNNs are also faster, efficient, and better for mobile-based processing. However, they can be a bit rigid and not that smart. However, VITs are masters at global reasoning thanks to this self-attention, and they use attention matrices, which is basically how each patch connects together. This makes them more flexible, where object locations can vary because you can always refer back to every single patch. VITs are also heavier and harder to run. However, on big hardware, they're perfectly fine. And they're also better for generalizing across different domains, especially with pre-training. But the main con with VIPs is that they require way more data than CNNs and are much more computationally expensive. So basically, if you have a small data set, use CNNs. Big datas and GPUs, VITs the move. Thank you so much for watching this video, and don't forget to like and subscribe. And if you're a real one who stuck till the end, here's a secret about CNN and VITs.
Psych!